First Hour Algebra 2. This is your Friday, March 20th video. We're going to review our exponent rules and how they relate to log rules, and then how to condense and expand logarithms, how to condense them, make them smaller, and expand them, make them larger. Okay, if we have an understanding of our basic exponent rules, which I think we do, and what are those? Well, when we multiply, what do we do when we multiply? We add exponents. So x cubed times x to the 7th, x to the 10th. If we divide, what do we do with our exponents? We subtract them. So when we divide, we subtract. And we raise a power to a power, x cubed raised to the 7th power, we multiply. So when we do a power raised to a power, we multiply our exponents. Okay. Now remember, logarithms and exponentials are related, so when we look over here at our exponent rules, we're going to see these same concepts. You know, our concept of when we multiply, we add. So in this logarithm, if we have a log of something that we are multiplying together, then that means we will see an addition over here. What will we be adding? We'll be adding a log plus a log. And it would simply be the log of A plus the log of B. If we see a division here, then that means over here we will see a subtraction, and it will be a log minus a log, and it will be the numerator A minus the log of the denominator B. Okay, so that's always numerator first minus denominator. If we have a power, remember we multiply, so we have a power here, an exponent on something in this logarithm. A power, we move it out front and we multiply. So we can relate these rules together. If we know these exponent rules, we can relate them to the log rules pretty easily. Okay, let's look at some examples. We will run through expanding logarithms first. Now when you expand something, you make it bigger. Now what's that mean to us, and how are we going to make this bigger? Well, we're going to go from having one logarithm to having more than one logarithm. Okay, now what would we do here with these two logarithms? Well, up here we are multiplying 6 times x. So down here we will add these two logarithms, and it would simply be log base 3 of 6 plus log base 3 of x. And our multiplication became an addition. If we have a division and we want to make this bigger, then that means we have a division here. So that means we've got to change it into some kind of a subtraction. Okay, what will we be subtracting? A log base 7 minus a log base 7. Well, log base 7 of what? The numerator x minus the denominator 5. So log base 7 of x minus log base 7 of 5. And if we have a power here, what do we do when we have a power? We multiply. So we're going to just simply take that exponent out front and multiply it by it. That'd be 9 times the log of x. And we have taken a small problem and we made it bigger. Small problem, made it bigger. Down here, don't see it so much, but it is bigger. Okay. Now we also need to be able to combine those. So here we have the log of x to the 5th divided by 7. So we have that division in there. So what's that tell me I'm going to do? I'm going to subtract something. What will I subtract? I'll subtract the log of the numerator, log of x to the 5th, minus the log of the denominator, log of 7. But be careful that make sure you're done when you think you're done, and we're not done here because we have an exponent right here. What do we do with the power? We move it out front and we multiply. So this will end up being 5 times the log of x minus the log of 7. Okay, making things bigger. All right, number 5, log base 8 of x to the 4th times y cubed. So sometimes it can help you just to read the problem and pay attention to what you're saying here. X to the 4th times, that means we have a multiplication. Means we need to change that into an addition. So it would be the log base 8 of x to the 4th. The two things we're multiplying together, x to the 4th plus the log of y cubed. We were multiplying an x to the 4th times a y cubed. So we split those apart with this addition. Now again, be careful. If we have exponents, we have to move those out front. So So our final answer here is going to be 4 log base 8 of x plus 3 times the log base 8 of y. There should have been an 8 on that logarithm right there. There we go. Now you got to be careful of your rules. Let's go back real quick. Notice in our rules we did not have any subtraction problems over here. That's a multiplication, that's a division, okay, and this is a power. Okay, and in here we don't have any subtraction rules. Multiplication, division, and a power. So we don't have anything over here that says log of a minus b equals something. And we also don't have one that says a plus b. So we don't have a rule if we're adding or subtracting inside of our logarithm, okay, which is what we're doing here on number 6. We are adding x plus 6. We're not multiplying x plus 6. We're not dividing x and 6. We're adding them. We don't have a rule for that, so it stays like it is. All right, the opposite or the other direction from expanding would be condensing, is when you make it smaller. Is when we make it smaller. How do you make it smaller? You're going to make it into a single logarithm. So see how we have more than one log in each of these problems. So we want to write a final answer that only has one logarithm. So in this case we want one single log base 6. Well, how will we do that? We'll say to ourselves, if we're adding these two together, what can we do with the 17 and the x? We can multiply them as 17x. In number 6 we have 2 log base 8s. We want 1. Well, what will we do? We would say we're subtracting these two. So that means it's a division. And what comes first? The numerator. What comes second? The denominator. So it's a log base 8 of the fraction x over z. Number 7, what do we have? Well, we got this 6 kind of in the way out front. So where did that sucker come from? Well, it came from an exponent. Let's put it back. Log base 3 of a to the 6th. And when you condense, you make it smaller. So we see how we have a big problem here, meaning 2 logs. We end up with a smaller problem, 1 logarithm. 2 logs down to 1 log. Here, not so much. All we see is we move the exponent back. Okay. Now again, we do have to be able to combine things, and primarily that's going to be when you have these numbers out front that you're multiplying by. Just remember, when you see those, the first thing you want to do is put them back up in the exponent. So this will be log base 2 of x to the 5th plus log base 2 of y cubed. Then handle the addition. And how we handle addition? We make it a multiplication. What are we multiplying together? An x to the 5th and a y cubed. So it would be log base 2 of x to the 5th y cubed. So just get yourself in a habit. If you see anything out front, like, oh, here we got a 5, so we got to put that back. That'd be the first thing you want to do. So it'd be log base 7 or log of 17 minus log of x to the 5th. Then say to yourself, where does this subtraction come from? It came from a division of what? 17 divided by x to the 5th. Numerator comes first, denominator comes second. Okay, and just for safety's sake and clarification, when you have a fraction, it's a good idea to put parentheses around them like that. Okay, so I hope everybody's doing okay. Hope this is working out. Trying to get the video processing issue straightened out on our end. We'll do what we can. Okay, we'll see you.